Assalamualaikum and a very good day. In this video, we are going to discuss on how to make an analog output out of NodeMCU. In order to make it easier for you to see the numbering for the connections, I'm going to use a simulator on the internet called Tinkercad. However, in Tinkercad, there's no NodeMCU ESP32. Therefore, I'm going to use Arduino UNO for its substitute. Bear in mind, I'll try to use the same pin numbers for all the connections so that you can connect it using the NodeMCU accordingly. First of all, we are going to connect the 3V3 pins and the ground pins to the breadboard. Use a red colored wire to connect the 3V3 to the breadboard and use a black colored wire to connect the ground wire to the breadboard. Next, we are going to put an LED on the board. Make sure the cathode of the LED is connected to the E21 while its anode on E22. Next, connect a jumper wire from D2 on the NodeMCU to A22 on the breadboard. This will connect the D2 on the NodeMCU with the anode on the LED. Next, connect the ground wire to A21. The best practice to connect the ground wire is to use a black colored wire. And for the signal wire, just use other colors than red or black. Once you finish connecting all the circuits, you can observe that there is no resistor being used in this circuit. As you might know, an LED might be broken if being put with the full power from the NodeMCU. To avoid overcurrent that will break the LED, there is a need to put a resistor on the circuit. However, for this video, we are going to use an analog output so that we can control the amount of current that coming out from the NodeMCU and use the LED without connecting with the resistor. Once you finish connecting all the components on the breadboard and the NodeMCU, it's time for you to go to Arduino UNO to do some coding. First of all, declare the pin for the red LED. We plan the signals to come out from D2 on the NodeMCU. So for this declaration, we are going to put RLED pin as number 2. Next, we go to setup and make a pin mode for RLED pin to be an output. Next, we are going to go to the loop function and invoke the analog write function. Set the pin number as RLED pin and the value to 100. For your information, the maximum number you can put here is 255 and the minimum number is 0. By setting it to 100, we are going to cut almost 45% of the voltage that coming out from the NodeMCU, therefore enabling us to use the LED without having to put any resistor on the circuit. Once you finish all the coding, verify your code by clicking on the tick button on the top left of the Arduino IDE. As you can see, you're going to get an error saying that the analog write function was not declared in the scope. This is due to the driver that have been put for the ESP32 of NodeMCU does not include any analog write function. In order to use analog output for NodeMCU, there is a workaround. So bear with me and follow all the codes. We need to declare several constants such as frequency, RLED channel, and resolution. In the setup function, you must put another two functions, that is LED C setup and LED C attach pin. At this time, the setup for the analog output is completed. Now we are going to go to the loop function to put some codes to control the output of the NodeMCU. Instead of using analog write, this time we are going to use the LED C write function. The function is almost the same as analog write. The first argument is the LED channel number, and the second argument is the value that is going to come out from the NodeMCU. The number is just the same as the analog write, which is 255 at the maximum and 0 is the minimum number that can be put inside this argument. When you finish coding this, verify your codes. Once it is verified, upload the codes to your NodeMCU. Once the upload is finished, observe the LED on the breadboard. The LED should be blinking with the interval of half a second. You should also observe that there's a blue LED on top of the NodeMCU that is blinking at the same time as the LED on the breadboard. If the blue LED is blinking but your red LED is not blinking on the breadboard, it means that there is something wrong with the connection on the breadboard and the NodeMCU. If there's no blinking on the blue LED on the NodeMCU, this means that there's an error or some mistake on the coding itself. Now if everything is okay, we want to have some fun with the connection that we have done. Change the code that you have on your Arduino IDE as shown in this video. In the loop function, we are going to make an incremental increase of the intensity of the LED brightness. We start off with 0, increase it 1 by 1 and stops at 100. And in the following lines, we are going to make it dim decrementally until it is 0. This increase and decrease will go on until the loop ends, which is until there is no more energy coming into NodeMCU. Once finished, verify your coding and then upload it onto your NodeMCU. You should see that the brightness of the LED is increasing and then decrease and then increase until the loop ends. Next, we are going to challenge ourselves to make multiple analog outputs. Duplicate the LED connections as before, but put it on the left side. Connect the grounds for the LEDs to the cathode of each LED. Connect the anode for the middle LED to D4 and the leftmost LED to D12. First, we are going to add another 2 LED channels onto the coding. We also have to declare 2 new LED pins for the new LEDs that have been put on the circuit. We don't have to duplicate the frequency and the resolution of the LED because the value is the same for all 3 LEDs. Add 4 more lines inside the setup function. The upper line to set up the channel, while the following lines is to attach the pin to the channel that have been selected. Next, we are going to put 4 more lines of function to control all the LEDs on the breadboard. Once finished, verify your codes and upload it on your NodeMCU. Once the upload is complete, observe the brightness of all LEDs. It should be bright and dim at the same time. This is because we put the same value I on all the LED channels. Try to have some fun with all the codings. Change the number of I. However, make sure that it's going to be less than 100 at all times. If the value is near 200, there are risks that you might blow your LED. I think with this you have mastered to control the analog output from the NodeMCU. Try to play around with the numbers and be creative at all times. I think that's all for now. Thank you. Until next time.